Hello guys, welcome to the final part of chapter 17. Okay, this is the last part of acid, bases and salt preparations, and in this video today, as your final topic, you are going to learn about acids and bases in terms of proton transfer. And you need to understand that acids are called acids because they are proton donors, they donate protons, and bases are proton acceptors. Alright, we'll get to it in a minute. Now, first thing is try to get these two sentences into your memory first. Okay, so an acid is a proton or hydrogen ion donor, and a base is a proton or hydrogen ion acceptor. So before anything else, I would like to talk about why hydrogen ion is called a proton. Okay, so if you guys know your periodic table, hydrogen is 1H1, right? So meaning that what it has one proton and one electron, and an ion is formed when an atom loses electrons. So when hydrogen atom loses the electrons, right, it's only left with the proton. So that is why a hydrogen ion is also called a proton. Okay, and let's see why we said acid is a proton or hydrogen ion donor. So in the reaction between hydrogen chloride aqueous and water, HCl is an acid because HCl donated H plus ion or a proton to water in order to form the hydrosonium ion H3O plus. Okay, and since H left, only Cl minus remained. So it works this way. Okay, HCl, since it is a covalent bond, they share a lone pair of electrons, and when H leaves from HCl, okay, so this bond can be represented as two electrons as well, right? So when this H leaves, Cl is left with the extra pair of electron here, and that is why Cl is minus, because normally Cl would have seven electrons, right? Because it's in group 7. But since hydrogen left, it's left with one electron, so it has one electron than normal Cl, and that is why Cl is going to be a negative ion. Okay, and let's take a look at this here. And HCl is an acid because it donated H plus ions to H2O, and H2O, water, is a base because it accepted H plus ions from HCl. And just a general knowledge, H3O plus is called hydrosonium ion. Okay, alright, so let's take a look at the reaction between some other acids and bases. Okay, so in this equation, NH3, ammonia, and hydrogen chloride is going to react, and we're going to figure out which one is the acid. Okay, so in order to get NH4Cl, okay, HCl needs to donate one hydrogen ion or one proton to NH3, and that's how NH4Cl is formed. If we try to write ionic equations, NH3 is simply ammonia, and HCl can be broken down into H plus and Cl minus. So what happened was HCl donated H plus ions to NH3. Alright, and as a result, NH4Cl comes to place. It becomes NH4 plus because it accepted H plus ion from HCl plus, and Cl is left alone with an extra electron, so it becomes Cl minus. So let's fill in the blanks below. HCl donates H plus ions to NH3, and NH3 accepts the H plus ions from HCl. Okay, and because HCl donates H plus ions, HCl is of course an acid, and because NH3 accepts H plus ions, it is a base. Okay, in exams, they will ask you about this equation and then ask you to explain why HCl is an acid in terms of proton transfer, and you need to be able to write down these following facts. Okay, it's very simple. So the general equation that we can always follow is the HA, and the A here represents an acid. Okay, when it reacts with water, it will form hydrozonium ion and a negative anion. Okay, this might look weird to you, but it's essentially saying that since it is acid, it could be anything such as HNO3, HCl, H3PO4, or H2SO4. It could be any acid at all. Okay. All right. So if we look, let's take a look at the equations in the next part. Now, when nitric acid reacts with water, let's write down the reaction that happens. Nitric acid is HNO3 aqueous, and water is H2O liquid. If they react, HNO3 is going to donate the H plus ions to H2O in order to form hydrozonium ions H3O plus. And since H plus ions left, nitrate is simply left as NO3 minus, and that is what's meant by the previous, this A minus. Okay. Alright, let's try to write down another one. Okay, now we have sodium oxide, which is Na2O. Okay, and when it reacts with water, what are we going to have? So Na is Na2 plus, and O is O2 minus. Alright, apologies, Na is not 2 plus, Na is, alright, let me write this again. Na is simply a positive ion, but since it's 2, we have 2 of them. Okay, and O is O2 minus. And so, as before, water is going to donate its hydrogen ion to Na2O to become NaOH, okay, which could be broken down into Na plus and OH minus. Okay, so that is why water is an acid and Na2O is a base. Okay, so remember that we wouldn't normally say that water is an acid, but that's why we're saying that it is in terms of proton transfer, water is an acid in this equation. For copper 2 oxide and sulfuric acid, we know that H2SO4 is an acid because sulfuric acid will donate H plus ions to CuO in order to form copper 2 sulfate and water. Now our final equation to learn today is ammonia and water. Okay, so ammonia is NH3 and water is H2O. It undergoes reversible reaction, and water is an acid because it will donate one hydrogen ion or one proton to NH3 in order to form NH4 plus. Okay, and then since one H left, imagine it this way. Okay, H2O is like this. So since one of the H left, we are only left with OH minus. Okay, now if you write full equation, it would simply be NH4OH. But rather than writing down ionic equations for this, what you need to be able to do is to tell the examiners which one is the acid and which one is the base, and why is it so. Okay, it is because an acid, the one that you think is acid, donates hydrogen ions or protons to your base. Okay, now in the following acid-base reactions, let's try to find out which one is an acid and which one is a base. Now in the first equation, carbonate ion plus hydroxonium ion, we get a bicarbonate and water. So in this equation, H3O plus hydroxonium ion is an acid because it donated one hydrogen ion to CO3 2 minus, and that's why it became this. Okay, so hydroxonium ion is an acid here, and CO3 2 minus is a base because it accepted one hydrogen ion or proton from H3O plus. Now in the reaction between magnesium oxide and sulfuric acid, H2SO4 is an acid because H2SO4 donated one hydrogen ion or proton to MgO. Okay, and that is why it is an acid. Now in the reaction between HNO3 and NH3, let's take a look at this. HNO3 is an acid because it will donate one proton or one hydrogen ion to NH3 in order to become NH4 plus. So it will be, since H left, NO3 is left as NO3 minus. In the reaction between H2SO4 and H2O, H2SO4 is an acid because it donated one hydrogen ion or proton to become hydroxonium ion, and since one hydrogen left, it becomes HSO4 minus. So H2SO4 is an acid. Now in the reaction between NH3 and HCl, HCl is an acid because it donated one hydrogen ion or proton to NH3. Okay, in the reaction between ethanoic acid or CH3COOH and NH3, now this time CH3COOH is an acid because it donated one hydrogen ion or proton to NH3 in order to become NH4 plus. So CH3COOH is an acid. If you want to go the other way around, you can also say that NH3 is a base because it accepted the hydrogen ion or proton from the acid. NH3 is a base because it accepted H hydrogen ion from NH3. Okay, so just to give a summary again, an acid is a proton or hydrogen donor. A base is a proton or hydrogen ion acceptor. And when in exams they will give you similar equations, and you should be able to explain why you think that one reactant is acid and one reactant is base. It is because the compound or the reagent that you think is acid donates H plus ions, and the base accepts the H plus ions. Okay, so this is the reason. Okay, if they ask you explain why HCl is an acid or explain why NH3 is a base, you should be able to write these down. Okay, these will usually give you 2 marks or more. That is all for today, and we have come to the end of Unit 3, Chapter 7, Acid, Bases, and Salt Preparations. Okay, I hope you learn from this video as usual, and I'll see you again next time.